All right, so in these videos, I'm going to show you how we can use our calculator because, of course, your fancy pants calculator can do all of this for you. If we're trying to find any normal distribution values, like we did for Bill's first example here, between two numbers, less than a number, greater than a number, we can do all of that within our calculator under the distribution menu. So distribution is second vars. This is the same place where we came and found the binomial distribution. So you're not ever really going to use norm PDF. But what we're going to do if we've got between two values is CDF. So we'll click on this one. Our lower bound is always going to start at whatever the lower bound is. For that first example with Bill, the lower bound was 6.19 because I was starting at 6.19 and going up to 6.61. So 6.19, 6.61, our mean, 6.4, and 0.21 was our standard deviation. If your calculator didn't look like my previous screen, when you hit norm CDF, you're just going to get an open parenthesis. You're going to put in the same four values separated with commas, the commas here. All right, 68.26%, exactly the same as what we got. So now I'm going to do this less than 5.98%. So remember we said at the beginning that this stretches on to negative infinity. So now my lower bound is actually negative infinity. Well, we can't type in negative infinity to our calculator. So what we type in instead is -1 times 10 to the 10th power. So this is just giving us a really, really big negative number. We wanted our maximum value to be 5.98. Same mu in standard deviation. Whoa. Oh, I know what I did. Let's say go to. I pushed the minus sign, not the negative sign. -1. Okay. 2.28%. 2.275. Super, super close. We can also draw these pictures like I've been drawing them. And that's what these pictures are showing down here. So the first thing you want to do is set your window. So our X scale, we want to be a little bit bigger than 3 standard deviations from the mean. Area under the curve is always 1. So we're going to go with a Y scale that starts with 0.1 to 1 and then readjust as necessary. So let's start off with that. So our window, oops. Actually, first thing you want to do, clear out all your graphs and make sure that none of your plots are turned on. Okay, now I'm going to go into my window. My mean was 6.4, so I'm going to do 6.4 minus, and then I want something a little bit bigger than 3, so I'm going to say 3.2 times my standard deviation. Do the same thing down here, 6.4 plus a little bit bigger than 3 times the standard deviation. All right, counting by 0.1s for that looks fine. My min, I want to show my x-axis, so I want to go just below it and then come up to 1 for my maximum. And again, I can count by 0.1s. Okay, so now I'm going to quit. I'm going to go back to my distribution. Distribution, second. And I'm going to draw. So I'm going to shade a normal distribution. Okay, let's do the first example again. So that one was 6.19 to 6.61. 6.4, 0.21. If you have a color calculator, all different kinds of colors you can pick. I'm going to say draw. Okay, so we can see that this is going up much higher. So I'm going to change my Y values to go up higher. Let's see what they changed it to here, 2. And we can say -0.5 just to give us a little bit more space. Count by 0.2s this time. If I hit graph again, notice it's no longer there. I need to repeat my drawing. And actually, I'm not sure if this is going to work if I went from 6.19, 6.61. Okay. All right. So here's my picture. And down here, I see my area. The thing with this is that sometimes you go to draw something else. So let's draw something else. Let's do the one, oops. Let's draw negative infinity to 5.98, and then 6.4 and 0.21. Sometimes what happens, and I don't know if I've done the right order of things, yeah. So this picture's still here and I don't want to see this picture anymore. So if I don't want to see this picture anymore, then what I need to do is go into draw. So that's second program, and then clear drawing and enter. And now if I repeat this command, I'm just going to see my one picture. There's one more calculator function that you need to know about, and there's no example for this on your paper. So the other thing that I want to show you with your calculator is that sometimes we're given an area and we want to find the value. So let's say that Bill's jumps, let's move that over some. So let's say that 72% of Bill's jumps are greater than A. Find A. So if we think about Bill again, here's a 6.4, 72% is greater than 50, greater than some value A here. So we know that this area is 72%. That means we know that this area is 28%. So there's a function on our calculator back in that distribution menu called inverse norm. And the way inverse norm works is it takes the area to the left of a value. Super, super, super key. So our area to the left of the value was 28%. You have to put it in as a decimal. 6.4 was our mean. 0.21 was our standard deviation. Okay, so estimating, this value is going to be less than 6.4 for sure. And if I wanted to go think about all my empirical values, adding all of this up, this is 68%. So it's going to be not quite 2 standard deviations away. Whoops. So adding all of this up would be greater than 72%. So it's going to be somewhere between 6.19 and 5.98. Right? And we get 6.28. So that makes sense for this value. So A, 6.28, not centimeters, meters. He's jumping more than centimeters. And that's using inverse norm. Okay, so I'm going to leave you to complete these other examples on your own. I'll complete the answers. You can look at them. And then I think Mr. Clement's going to give you a worksheet on inverse norm as well.